Welcome back, students. In the previous video, we have discussed the topic energy. So, in this video, we will continue our chapter 11, and the next topic is law of conservation of energy. Students, this is a very important topic in every aspect. So, listen it carefully. Law of conservation of energy. What do you mean by conservation? Conservation means constant, fixed. So from here we get an idea that the total energy of a body remains fixed. How we can define this law? According to this law of conservation of energy, energy can neither be created nor destroyed. The total energy of a body or any change, the total energy of a body remains constant. This is our law of conservation of energy. We can also add one line in that energy only converted from one form to another. Only converted or changes from one form to another. एनर्जी एक टाइप से दूसरे टाइप में कन्वर्ट हो सकती है, बट दैट डजंट मीन दैट यू डिस्ट्रॉय द एनर्जी. दिस इज आवर लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. द मेन पॉइंट हियर इज द टोटल एनर्जी ऑफ ए बॉडी रिमेन्स constant. How we can understand this, or if I say how we can prove this law of conservation of energy, let's consider a very simple example. Suppose this line is representing our earth surface, and here is another surface at a height h from the ground. That means we are at a height h here, and we are having a body of mass m. The mass of this body is m, and initially it is at a point A. So what type of energy possessed by this body? As this body is above the earth surface, so it have some potential energy, and we are holding it. It is not in motion. So what we can say about its kinetic energy? We can say that at point A, here I am deriving. You can also make a heading for derivation, that I am deriving or proving this law. At point A, the body have potential energy but zero kinetic energy. Why? Or if I write it in clear form, that potential energy of the body is mgh, and what will be its kinetic energy? Its kinetic energy is 0 because the body is at rest. Now what happened? Suddenly I dropped this body. As this body starts in motion, it will come down. H will goes on decreasing. That means its potential energy will decrease, and as it comes in motion, it gains some kinetic energy. Suppose the body is here in between the path. Let this distance is h by 2, and at point B, what type of energy is possessed by the body? As the body is above the surface, if this is h by 2, this is also h by 2, the body is having some potential energy, And also as the body is moving under gravity, so it has some kinetic energy also. How we can write both the terms? At point B, the potential energy of the body is mg, but this time the height is h by 2. What will be its kinetic energy? Kinetic energy is half mv square. This is its kinetic energy. For right now, we don't know what is the value of velocity, but we know this much that the body is in motion, so it must possess some kinetic energy. As soon as the body reaches the ground, here, the body comes here now, what will be its potential energy? Now its potential energy is 0, and as the body comes down, it must have some kinetic energy. So what we can write about the energy of body at point C? What we can say? At point C, the potential energy of the body is 0. Why 0? Because here H is 0. What we can say about its kinetic energy? Its kinetic energy is half m. Suppose I write it as V dash, so that there is no confusion between this V and this V. The body is having kinetic energy as half mv dash square. Our main motto here is that we are going to prove law of conservation of energy. That means total energy of the body remains constant. So how I can calculate the total energy now? Total energy means sum of all the energy possessed by the body. Also, we have a specified term for addition of kinetic as well as potential energy, and that we named as mechanical energy. Mechanical energy means addition of kinetic energy and potential energy, or you can simply say kinetic energy and potential energy both combine form mechanical energy. So now we will write total energy at all the points. At point A, the total energy is mgh plus 0, that means it is mgh. Now at point B, what will be the energy? It is mgh by 2 plus half mv square. How we can calculate the value of V? We will use third equation of motion. And what is that third equation? That V square minus U square is 2AS. Initially the body is at rest, so we can take it as 0. So we are left with V square equals to 2AS. Now A will be G, and what will be our S? Distance covered is h by 2. So we will write this here. It will be mgh by 2 plus half m. In place of v square, I will write 2gh by 2. It will get cancelled out. We are left with mgh by 2 plus mgh by 2. Total it becomes mgh again. That means our energy is mgh here and total energy is mgh here also. Now one more point is there. Let's discuss about that point also. At point C, what will be the total energy? Potential energy is 0, but kinetic energy is half mv dash square. Can we prove that this energy also comes out to be mgh? How? We will calculate the value of v dash square by using third equation of motion. So what will be our u? From the starting point, u is 0. And what will be the total distance covered? It is v dash square as 2gh, half into m into 2gh. So again our answer will comes out to be mgh. As the total energy is mgh at every point, that means we can say that the total energy of the body is constant. Here potential energy is decreasing, here it is maximum and then it comes down to 0. And the kinetic energy is initially 0 but here it becomes maximum. So what we can say? We can say that the decrease in potential energy is equals to gain in kinetic energy or increase in kinetic energy of the body. जितना बॉडी की पोटेंशियल एनर्जी डिक्रीज हुई है उतना ही बॉडी ने काइनेटिक एनर्जी गेन की है. सो हमारे पास किसी भी तरह का लॉस नहीं हुआ है. एनर्जी जस्ट चेंजेस फ्रॉम वन फॉर्म टू अनदर. सो दिस इज आवर टॉपिक अबाउट लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. One more topic is there related with energy, and that is energy transformation. Transformation. What is the meaning of transformation? As you know, the meaning of transformation means change or converting into another form. So, what about energy transformation? Energy transformation means conversion of energy from one form to another. That means simply conversion of energy from one form to another. एक एनर्जी टाइप का किसी भी दूसरे टाइप में कन्वर्ट होना क्या होगा? एनर्जी ट्रांसफॉर्मेशन. फॉर एग्जाम्पल वी आर हैविंग इलेक्ट्रिक बल्ब. हम पहले इलेक्ट्रिक बल्ब यूज करते थे. हाउ मेनी टाइप्स ऑफ एनर्जी इज इन्वॉल्व इन इलेक्ट्रिक बल्ब? एक इलेक्ट्रिक बल्ब ऑपरेट होता है इलेक्ट्रिसिटी से. दैट मीन्स इट हैव इलेक्ट्रिकल एनर्जी. और उसकी वजह से क्या होता था? दैट बल्ब विल स्टार्ट ग्लोइंग. इट विल प्रोड्यूस लाइट एनर्जी. और उसके साथ साथ आपका बल्ब गर्म भी होता है. सो इट विल प्रोड्यूस सम हीट एनर्जी ऑल्सो. सो दिस इज द एग्जाम्पल ऑफ एनर्जी ट्रांसफॉर्मेशन. दैट इन एन इलेक्ट्रिक बल्ब electrical energy is converted into light energy and heat energy. Similarly, if we will take example of electric fan, what kind of energy is there? Electric fan is operating with electrical energy. So this electrical energy is converted into, it will give us winds. It starts moving. So this electrical energy is converted into mechanical energy, by which the blades of the fan starts rotating. The electrical energy is converted into mechanical energy. Similarly, we are having an electric iron. What is the energy transformation here? In electric iron, electrical energy is converted into heat energy. Solar cell is the next example. In solar cell, what kind of energy is there? Solar cells are operating on sun energy. That means solar energy. And what we will do? We can light up the bulb. So solar energy is converted into light energy. We can use it directly as the water heater. So it will convert into heat energy also. We can use in place of electricity also. So we can write solar energy is converted into electrical energy. So these are some examples of energy transformation. where energy is transformed from one form to another. Similarly, you can find many more examples where energy is transformed. For that, you can read your book. So, our next topic for the chapter is power. What is power? सुना है आपने कि ये इंजन इतने हॉर्स पावर का है, that HP is written there. Students, do one thing. बाइक या स्कूटी तो सभी के घर पे होती हैं, it's usual. So check what HP is written on the engine of your bike or scooty. किसी भी इंजन मोटर की जो पावर है वो HP में लिखी होती है, and that HP means horse power. So firstly we will discuss our topic power. What is power? Power simply defined as rate of doing work. किसी भी काम को करने की जो आपकी कैपेसिटी है उसे हम बोलते हैं पावर. एंड कैपेसिटी इज डिसाइडेड विद रिस्पेक्ट टू टाइम, कि आप कितना जल्दी किसी भी काम को करते हैं. सो द सिंबल फॉर पावर इज P, एंड वी विल मेक अ फॉर्मूला फॉर इट, दैट इज वर्क डन पर यूनिट टाइम. वर्क डन पर यूनिट टाइम इज पावर. The SI unit now comes on SI unit. How we will measure this? The SI unit of power is watt. 1 watt. 1 watt means when you do 1 joule of work in 1 second, then the power is said to be 1 watt. जब भी 1 जूल काम 1 सेकंड में होता है तो हम ये कहते हैं कि उस बॉडी की पावर जो है वो 1 वाट है. The formula for power is simply work done per unit time. As we know, the work and energy both are same thing. So you can also write here energy consumed in a given time is also named as power. आपने कितना काम किया है किसी भी टाइम में वो भी पावर है. आपने कितना एनर्जी कंज्यूम या यूज्ड किया है in a given time, that is also power. So in this way we can define simply power. If numericals are come, how we will solve? Suppose you are having an electric bulb of 100 volt. आपके पास एक 100 वाट का बल्ब है और आप उसे 10 मिनट्स के लिए ऑपरेट करते हैं. You are operating it for 10 minutes. This is the power and this is time. How much electrical energy is consumed by it? How you will calculate? We will simply use the formula that power is energy per unit time. This one value is 100, energy we have to calculate, and time is in 10 minutes. So we will convert it into second because second is the SI unit for time. So our answer will be 600 multiplied by 100, it is 60,000 joule. This much is the energy consumed. But here one more interesting concept is there. Whenever there is a term about electrical energy consumed, we will use a special word that is unit. घरों में भी आप सभी ने सुना होगा ना कि बिजली की इतनी यूनिट खर्च हो गई है हमारे पास. That unit is named as the commercial unit of energy. Especially we will measure the electrical energy consumed in it. And what is its value? 1 unit means 1 kilowatt hour. It simply represents electrical energy consumption. आपने कितना इलेक्ट्रिकल एनर्जी कंज्यूम किया है इन ए गिवन टाइम, दैट हैव स्पेसिफाइड नेम, दैट इज 1 kilowatt hour, and this is equals to 1 unit. किलोवाट इज द हायर यूनिट ऑफ पावर. जैसे हमारे पास ग्राम, 1000 ग्राम इज इक्वल्स टू किलोग्राम. सिमिलरली 1 kilowatt is equals to 1000 watt. And one more unit for power is that I was discussing ahead, HP. HP means horsepower, and 1 horsepower is equals to 746 watt. So this is the topic about power and energy. How we can relate both these energy, as this is also unit of energy and we know that the energy of unit is joule also. So how we can relate both these type of energy, commercial unit of energy and also the SI unit. What is the relation between them? Students, for many of the students I found that this topic is confusing for them. They get confused, either they have to write joule or the kilowatt. Commercial unit of energy. This commercial unit of energy is 1 unit, or simply 1 kilowatt hour, and the SI unit of energy is joule, or you can simply write it as J. Now our question is, we have to relate 1 kilowatt hour and joule. How we can relate? Focus here. The formula for power is work done per unit time, or you can say energy used per unit time. So if we have to find out the value of energy, what we will do? Energy is power multiplied by time. In terms of SI unit, what we will write the SI unit for energy? Joule. For power it is watt, and for time it is second. This is our SI unit. And if we have to write the commercial unit, what we will write? It is 1 kilowatt hour. Means kilowatt is the power and it is multiplied by hours, that is time. So what we will do? We will simply do kilowatt. 1 kilowatt is equals to 1000 watt, and 1 hour. 1 hour means 3600 second. So what we will get? We will get 3600 multiplied by 1000. So I can write the 3 more zeros here. It is watt second. And as written above, 1 joule is equals to 1 watt second. That means 1 kilowatt hour is equals to, I can write it in exponential form. Here 5 zeros are there. So I will make a similarity. 3.6 into 10 raised to the power 6. In place of watt second I write joule. So in this way we derived a relation between kilowatt hour and joule. That simply means अगर कोई भी device this much amount of energy in joule, इतने joule energy खर्च करता है, that is equals to 1 electrical unit or 1 kilowatt hour. Let's do one numerical also to clarify the concept. Suppose you are having an electric iron whose power is 800 watt and you operate this for 2 hours continuously. How much electrical energy is consumed by it? You have to calculate energy. So what you will do? You will simply multiply power and time. As we have to calculate the units of energy, so what we can do? For the easiest way, we will write it as this is in watt. So we will multiply it by 1000. It becomes kilowatt now. And the time is already given in hours. So we can cancel out like this. It will be 16 by 10 kilowatt hour, or we can simply write it as 1.6 units. That electrical iron will consume 1.6 unit in 2 hours. If it is asked to us that calculate the electricity bill, if the cost of 1 unit is 4 rupees, then how we can calculate the bill? We will simply multiply 1.6 by 4. So in this way we can calculate our electricity bill also. So this concept is having its practical application. That's all for topic work and energy. Today we have completed our chapter. If you have any doubt, you can ask in the comment section. Thank you. Have a nice day.